Hello everyone, my name is Sachin and I'll be discussing the paper for part test 2, the mathematics paper in part test 2. So let's look at the first question. Limit x tends to 1 minus x times tan of pi x by 2. So you can observe that this limit is of the form 0 times infinity. That's because as x tends to pi by 2, remember tan x does not have a limit, but at pi by 2 plus, tan x tends to minus infinity, whereas while x tends to pi by 2 minus, tan x tends to plus infinity, which means that as x approaches 1, this term tan of pi x by 2 will approach either plus infinity or minus infinity. So that is why this is in the form 0 times infinity. So what we can do is we can convert it to the form 0 by 0 by writing tan of pi x by 2 as 1 by cot pi x by 2. So now I can write 1 minus x by cot of pi x by 2. Now this is in the form 0 by 0, which you can solve using standard methods. You can use either L'Hopital rule or you can try to apply any standard limit, right? So proceeding here, you get limit x tends to 1. If I differentiate the numerator, I get minus 1. If I differentiate the denominator, I get minus cosecant square pi x by 2 times pi by 2, right? And as x tends to 1, this limit approaches 2 by pi, which is why the answer is D, 2 by pi. The second question, for all x belongs to R, as limit x tends to infinity. So here you observe that the limit is of the form 1 par infinity, because as x tends to infinity, 1 by x tends to 0. And you can write x minus 3 by x plus 2 as 1 minus 3 by x divided by 1 plus 2 by x, right? By dividing x in both numerator and denominator. Now as 1 by x tends to 0, these terms in the numerator, minus 3 by x in the numerator will tend to 0. So minus 3 by x will tend to 0. 2 by x will also tend to 0, which means the value of the limit will be 1, because the entire expression will tend towards 1. So this tends to 1. So the limit is of the form 1 par infinity. So if limit x tends to a, if limit x tends to a, f of x power g of x is of the form 1 par infinity, right? Then it can be rewritten as e power limit x tends to a, f of x minus 1 times g of x. So a very important result that you can use in limits of the form 1 par infinity. But do remember that this is only applicable if the limit is of the form 1 par infinity. So here f of x is x minus 3 by x plus 2. G of x is x. So the required limit will be e power limit as x tends to infinity, x minus 3 by x plus 2 minus 1 whole times x, right? So this will become limit e power limit as x tends to infinity. In the numerator, I will get minus 5. So minus 5x by x plus 2. And remember, just like we did with the expression x minus 3 by x plus 2 here, you can also divide both numerator and denominator by x. That will give you minus 5 in the numerator, 1 plus 2 by x in the denominator. And remember here, as x tends to infinity, 1 by x tends to 0, right? Which means this term 2 by x will again tend to 0, and your answer will be e to the power minus 5. So the answer to question 2 is e to the power minus 5. Okay, let's go to the next question here. Given f of x is differentiable at x equals 1. So this is a rather simple one, because what is the condition for differentiability? The first condition for differentiability is the function should be continuous. So for the function to be continuous, f of 1 should be equal to the left limit, and it should also be equal to the right limit. So here, what is f of 1? Because equality is given on this side of the, on this side, right? So, equality is given on this side, right? So f of 1 is nothing but what you get by substituting 1 in place of x square e power 2 times x minus 1. So I have 1 square e power 2 times 0. And for the left limit, you have to calculate limit as x tends to 1, x square e power 2 times x minus 1. That's because you're calculating left limit. You take the definition for x less than 1. And this should also be equal to the right limit. This will be limit as x tends to 1, a times cos of 2x minus 2 plus bx squared. Right? So what you observe is that f of 1 is 1. The left limit is 1. The right limit, if you substitute x equals 1, you get a plus b. And that gives you your first condition, that is a plus b should be equal to 1. Right? This is the condition for continuity. Now for differentiability, you can apply the condition for differentiability, that is the left derivative at 1 should be equal to the right derivative at 1. Right? Now, generally, what is the definition of left derivative? Generally, the left derivative is nothing but limit as x tends to 1 minus f of x minus f of 1 by x minus 1. And the right derivative is limit as x tends to 1 plus f of x minus f of 1 by x minus 1. Right? So this is generally the formula for the left derivative and the right derivative. But if you know that the function is continuous, then you can differentiate the individual parts. What I mean is to find the left derivative, to find f dash of 1 minus, you can find the derivative of x square e power 2 times x minus 1, right? And then substitute x equals 1. And for the right derivative, you can differentiate a cos of 2x minus 2 plus bx square at x equals 1, right? So this can be done only if that particular function is continuous at that point. So anyway, so f dash of 1 minus is the derivative of this function will be derivative of x square times e power 2 times x minus 1 will be x square times e power minus 1 into 2, because first I'm differentiating e power 2 times x minus 1 plus e power 2 times x minus 1 times 2x, right? So this calculated at x equals 1 will give you, so this is 1 into 2 plus, so 2 plus 2, 4. The left derivative is 4. The right derivative, if I calculate, I get minus a sine 2x minus 2 into 2 plus 2bx. So this calculated at x equals 1 is 2. Right? So from here we get 2b equals 4, which means b equals 2, and therefore a equals minus 1. Right? We have 2b equals 4. You already have a plus b equals 1. So solving, you get a equals minus 1, b equals 2. Question 4. Let u bar be a vector coplanar with the vectors a bar and b bar. So generally, if a vector is coplanar with a bar and b bar, then we can say it is of the form alpha a bar plus beta b bar. Because any vector coplanar with a bar and b bar can be written as a linear combination of both of them. But here there is an additional condition. U bar is perpendicular to a bar. U bar is also perpendicular to a bar, which means u dot a must be 0, right? But now you can write u bar as some constant times a cross of a cross b. It's a very useful trick when dealing with a vector that is coplanar with a and b and also perpendicular to a, right? So here this applies to, so when you have only coplanar with a and b, then you can write alpha a bar plus beta b bar. But if you know that the vector is coplanar with a bar and b bar and also perpendicular to a bar, then you can write u bar is lambda times a cross of a cross of a cross, right? Yes. Similarly, if the condition is that the vector is coplanar with a bar and b bar, and perpendicular to B bar, then you can assume that U bar is lambda times B cross of A cross B, right? So in this particular question, we don't need two unknowns, we can use one unknown. So here I will assume that U bar is lambda times A cross of A cross B, right? And then another condition is given U dot B equals 24, which means you can write lambda times A cross of A cross B whole dot B equals 24, right? So once you have uh, A bar and B bar, you can calculate A cross of A cross B, then take its dot product with B and then equate it to 24, right? So this is how you get U bar in this question. And then from that, you can calculate modulus of U bar square. Question 5, the distance of 1 comma 2 comma lambda from the line. So what information is given about this line? The information we have about this line is that it passes through a fixed point 0 comma 0 comma 0, because we can rewrite the given line as x minus 0 by 3 equals y minus 0 by 0 equals z minus 0 by 4. So these terms in the numerator help us find out the fixed point on the line, right? And the denominator gives you a vector parallel to the line. So what is a vector parallel to the line? I can say it as 3 I cap plus 4 k cap. There is no y component because this y component is 0. Now you have distance of 1 comma 2 comma lambda from this line, right? So let us say you have a point 1 comma 2 comma lambda and you want to find the perpendicular distance from this point to the line, right? Which means there will be some point here which lies on the given line. Now, how do I assume such a line, such a point? So you assume that the given line equals some parameter t. From here, I will get x equals 3t, y equals 0, z equals 14. So any general point on the line can be written in the form 3t comma 0 comma 14. 3t comma 0 comma 14. So let us take a stock of all the points that were mentioned in this diagram. You have the origin, which is O. You have a variable point on the line, which is A, and you have the point, right? Now, two conditions are given. What are they? The first condition is AB is 2, right? So the distance between these 2 points is 2. The second condition is A is the foot of the perpendicular. So what will the second condition be? It will be that you have this vector AB bar. So you can observe one thing here. You have a vector AB bar. You also have a vector OA bar. Now, because the angle at A is 90 degrees, the angle between these two vectors should also be 90 degrees, which means you get your second condition, AB bar dot OA bar should be 0. And here when I say AB equals to, I mean magnitude of the vector AB bar is 2. So you will need two conditions because there are two unknowns here. One unknown is lambda, the other is t. So to solve them, you will need two conditions. And from that, you can find out the value of lambda. So that was question 5. It is also useful even if you want to find the foot of the perpendicular. The same question, if I'd asked you to find the foot of the perpendicular, then you would be solving using the same method. Instead, you'd be interested in the value of t, right? So question 6, A, B, C are 3 given vectors. You will notice that there are 2 unknowns here. B1 and B2 are there, right? So B1 and B2 are unknowns, which means when you start solving the question, keep this in mind. You are looking for two conditions. You need a minimum of 2 conditions if you want to find the vector B bar, right? Now, let's look at the other information given. Projection of B on A is A. So here, when they say projection of B on A, they mean the vector projection. That's why it is A bar. So what is the vector projection of B on A? It is B dot A by mod A square times A bar. Right? This is the vector projection. Now this is given as a bar. This is equal to a. Now that means that the scalar on the left hand side, that is, what is the scalar on the left hand side? It is b dot a by mod a square. This should be the same as the scalar on the right hand side. The scalar on the right hand side is 1, right? So you get your first condition here, b dot a by mod a square is 1, or I can write b dot a equals mod a square. That gives me the first condition on b1 and b2, right? Then you have a second condition, a plus b is perpendicular to c. So that means a plus b dot c equals 0, right? So you are given two conditions, b dot a equals mod a square and a plus b dot c equals 0. If you solve them, you will get the values of b1 and b2. And based on that, you will get modulus of b bar. So let us move to the next question here. Question 7, a bar, b bar, c bar are coplanar vectors. So what is the condition for three vectors to be coplanar? It is box product of a bar, b bar, c bar is 0. And here the three vectors are given in terms of ijk, which means to calculate the box product, you just need the determinant of the coefficients. So the first row will have 1, 2, 4. The second row will have 1, lambda, 4. The third row will have 2, 4, lambda square minus 1. Equate this to 0, you will get 1 or possibly more values of lambda. You have to pick a suitable value of lambda such that a cross c is non-zero, right? And you might think of why a cross c could be 0, right? That is because there is a situation where box ABC equals 0 also includes a condition where a is parallel to c, right? If box ABC is 0, it could also be because a is parallel to c. That is why you have to be careful about this. Here, a should not be parallel to c, and you must still get box ABC 0, right? That explains the multiple values of lambda in this question. Question 8, two lines intersect at a point R. So this is also something that is commonly used in competitive exams from 3D geometry. If two lines intersect, sometimes we are interested in finding their point of intersection, right? So for that purpose, you just have to follow what we did in one of the previous questions, which is, see, the point of intersection has to be a point on the first line and also a point on the second, which means it can be written in terms of a general point on the first line and also in terms of a general point on the second line. So how do I write general point on the first line? So equation of the first line is x minus 3 by 1 equals y plus 1 by 3 equals z minus 6 by minus 1. Let it be equal to some parameter lambda. From here, if I solve, I will get x equals lambda plus 3, y equals 3 lambda minus 1, and z equals minus lambda plus 6. So this represents a general point on the first line. Similarly, to get a general point on the second line, so x plus 5 by 7 equals y minus 2 by minus 6 equals z minus 3 by 4, equated to some parameter mu, right? So you get a general point on the second line, which is 7 mu minus 5 minus 6 mu plus 2, 4 mu plus 3, right? Now, for the point of intersection, it should be of the form lambda plus 3, 3 lambda minus 1 minus lambda plus 6. It should also be of the form 7 mu minus 5 minus 6 mu plus 2, 4 mu plus 3. That means for some value of lambda and some value of mu, both the general points coincide. And when they coincide, they will represent the point of intersection. So here, to find the point of intersection, you have to equate the x, y, and z coordinates of the general point. So lambda plus 3 equals 7 mu minus 5. 3 lambda minus 1 equals minus 6 mu plus 2. And minus lambda plus 6 equals 4 mu plus 3. Right? So you have three equations. If you're able to solve them to find the value of lambda or the value of mu, you will get the point of intersection. Right? Now we have two unknowns here, lambda and mu. However, we have three equations. So what is the reason for this? Because if I want to solve for lambda and mu, two of the three equations are sufficient. So what is the third equation doing? So that can be answered by one important observation. The values of lambda and mu that you get from the first two equations should satisfy the third equation automatically if the lines intersect. If that doesn't happen, then it means that the lines will definitely not intersect, right? So you, based on the value of lambda, you will get the coordinates, and then you have to find the reflection of this point in the xy plane, right? So what is the reflection of a point in the xy plane? What happens when you take a reflection of a point with respect to the xy plane? It is simply that the sign of the z coordinate is reversed, right? So if you have a point x naught, y naught, z naught, and you want to find its image with respect to xy plane, that is the plane z equals 0, the image will be x naught, y naught minus z. Similarly, if you take reflection with respect to yz plane, the sign of the x coordinate is reversed. If you take reflection with respect to xz plane, then the sign of y coordinate is reversed, right? So two important ideas in this particular question. So once you solve for lambda and mu, you will get the point R and then its reflection. Question 9, alpha is given, beta is given, and beta is of the form beta 1 minus beta 2, right? So here you have beta 1 is parallel to alpha bar, which means beta 1 should be some scalar multiplied by alpha, right? Two vectors are parallel, then each vector should be written as a scalar multiple of the, each vector can be written as a scalar multiple of the other. So here beta 1 can be of the form lambda alpha, right? So that gives you beta equals lambda alpha bar minus beta 2 bar. Now the second piece of information we have is beta 2 bar is perpendicular to alpha, which means beta 2 dot alpha should be 0, right? So to apply that condition, here we will take dot product with respect to alpha on both sides. So that will give beta dot alpha equals lambda times alpha dot alpha minus beta 2 dot alpha, right? Now we know that beta 2 dot alpha is 0, which means beta dot alpha equals lambda times mod alpha square, right? So from here, you will get the value of lambda. Lambda is nothing but beta dot alpha by mod alpha square. So what is beta dot alpha here? 6 minus 1, 5. And mod alpha square is 10. So you have lambda is 1 by 2, right? Which means substituting here, you get beta bar equals half alpha minus beta 2, right? So from here, you get beta 2 bar, which is half alpha minus beta. And we already know beta 1 bar is half alpha, because remember we started by assuming that beta 1 bar is lambda alpha bar, right? Now all you have to do is find beta 1 cross beta 2, right? That is what is asked. Beta 1 cross beta 2 is to be found. So I hope that was clear. We had two important pieces of information here. So one is beta 1 is parallel to alpha bar, and second is beta 2 is perpendicular to alpha, right? So that was question 9. Question 10. So question 10 is uh, one of those questions that can get potentially lengthy if you do not have an elegant solution. So one thing I always recommend is that if you are trying to find a vector b bar, do not assume that it has three components x, y, z right away. Because if you have three unknowns x, y, and z, you will need to solve three equations, right? So in this particular question, we'll try to solve this without having to assume that b bar is x, y, z, x I cap plus y k, j cap plus z k, right? Beta a, let b bar equal x I cap plus y j cap plus z k cap is one solution, but it is going to be lengthy. We'll discuss why that happens. But first, let's look at this question, right? So a cross b is c bar and a dot b is given. A dot b is 3. So I have a cross b equals c. And c is also given, right? Now, what I can do is I can take cross product with A on both sides. That is because I know what C cross A is going to be. I have information about C. I have information about A. If I take cross product with respect to A on both sides, two things are solved. First is the right hand side is C cross A. More importantly, the left hand side can be simplified as A dot A times B minus B dot A times A, right? The left hand side is a triple product, vector triple product, and can be simplified this way. So I will get equals C cross A, right? Now from here, I have B dot A is 3 and A dot A is mod A square, right? What is A dot A here? Mod A square, that is 3B bar. And here B dot A is given as 3. So this is 3A bar equals C cross A. That means I will get B bar equals C cross A by 3 plus A bar, right? So now I get B bar, I can find its magnitude. So what you observe here is that I have not used any unknowns, but if I were to use unknowns, then I have A cross B equals C and A dot B equals C. I would have to write two equations, right? The first equation would be A cross B equals C. That is, I have to take determinant I cap, J cap, K cap, then 1, 1, 1, X, Y, Z, and equate it to the vector J cap minus K cap, right? This is one thing. The second thing is A dot B equals 3, which means I would have to write X plus Y plus Z equals 3, right? It becomes lengthy when you're trying to solve for many unknowns. Here, it is useful to simply take cross product of A on both sides. And please remember, how do I know that I have to take cross product on A of or with A on both sides? Because reason one, we have C and A. Reason two, we have information about A dot B, right? So that was question 10. Question 11 is rather simple. It's an application of the section formula and then the dot product, because so you have three vertices of a triangle. So let us take some random triangle, not assume that it has any special properties, but you have A and then you have B and then you have C. M is the midpoint of AC and G divides BM in the ratio 2:1. So indirectly, you are being asked to find the centroid of the triangle, right? Isn't that the case? If M is the midpoint of AC, then BM is the median. And what divides the median in the ratio 2:1? The centroid, right? If the numbers had been different, then you would have to calculate M differently and G differently. For example, if I had said M divides CA in the ratio 3:4 and G divides BM in the ratio 7:8, then you would have to use section formula to calculate G, right? Anyway, so here, because the concept of a centroid has been disguised in these two statements, right? Those who are alert can catch hold of this and save time by directly calculating the centroid. So what will the centroid be? Centroid is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. So here the centroid will be 2, 4, 2. Now we need to find cosine of the angle GOA. So you have the point G, you have the origin, you have the point A. So if you want to find GOA, you have to consider two vectors which start with O, right? Because the angle is being formed here. This is the angle you want to find. You have to form two vectors which start from O. So two such vectors are OA bar and OG bar, right? And if this angle is theta, then what is cos theta? It is OA dot OG by mod OA times mod OG. So that will give you the cosine of the angle, right? Important thing to remember here. If you want to find an angle formed at a point, then the two vectors you use must start from that point, right? Question 12. The point lies on the line segment joining these two points and the distance of R from the origin is. So what is the necessary condition for 3 points to be collinear? Because R lies on the line segment joining P and Q. That means, so let us say this is P, this is Q, R lies on this line segment. So when will that happen? It will happen when the 3 points are collinear, right? And what is the condition for 3 points to be collinear? It is that the direction ratios of PQ and PR are proportional, right? Here, if I take the direction ratios of PQ or direction ratios of PR, they should be proportional. So what are the direction ratios of PQ? That I can write as 6 comma 3 comma 6, x2 minus x1, y2 minus y1, z2 minus z1. And what are the direction ratios of PR? PR would be 2 comma y plus 3 comma z minus 4, right? So now these two sets of DRs must be proportional, right? So you get 6 by 2 equals 3 by y plus 3 equals 6 by z minus 4. And once you solve this, you will get the values of y and z, and then you can calculate the distance of r from the origin, right? So this concept, direction ratios are proportional, is also useful when you're trying to write the condition for two lines to be parallel, right? Here, if PQR are collinear, then definitely PQ and PR must be parallel. That is why we have taken the direction ratios to be proportional. So question 13, the projection of the join of the points. So 2 points A, B are given, right? 2 points A and B are given, and a line whose DCs are given. So that means a vector parallel to the line is also given. Let us call this N bar, right? Now, generally, what is the projection of, we discussed this again in the previous question. What is the projection of A bar on B bar? This is nothing but A dot B by mod B. This is the scalar projection. In the earlier question, we discussed the vector projection. So here I want the projection of AB bar on N bar. So what do I need to find? I need to find AB bar dot N bar by modulus N bar. All the required information is given so that you can calculate AB bar, and from there you can find AB dot N and divide it by modulus N. Question 14, if the function has a local maximum at the point 2, 10. So what is the condition for local maximum? It is that the first derivative at that value of x should be 0, and the second derivative at that value of x should be less than 0, right? Additionally, there is one piece of information here that is useful. The function itself contains the point 2, 10, which means f of 2 should be 10. So I think here we need to check if the three conditions are satisfied, because it is not necessary that if the first derivative is 0 and the value of the function is 10, it is not necessary that this condition is also satisfied, right? So let's apply the condition there. F of 2 is 10 would mean 2a times e power minus 2b equals 10, right? And f dash 2 is 0 would mean the derivative. So ax times e power minus bx times minus b plus e power minus bx times a evaluated at x equals 2 is 0. So that means minus 2ab e power minus 2b plus a e power minus 2b equals 0. So yes, it is quite possible that you get an answer here, but please make sure you check whether the second derivative is negative. If the second derivative is not negative, then even if you get a value for a and b, that may not be the correct answer, because for the local maximum, the second derivative test is also very important, right? So here I can say that a e power minus 2b is 5. If I substitute that here, I get minus 10b plus 5 equals 0. So b is 1 by 2. And if b is 1 by 2, then a will be 5e, right? So a equals 5e, b equals 1 by 2 is seems to satisfy the condition here, but make sure that this condition is also met, right? Only if this condition is met, then you can say that it is a local maximum. Otherwise, the answer could also be none, because it is quite possible that you take any value of A and B, all three conditions are not met, right? So that was question 14. Question 15. L1 and L2 are side lengths of two variable squares S1 and S2 respectively, right? The rate of change of area of S2 with respect to rate of change of area of S1 when L2 equals 1. Okay. So here when L2 equals 1, all right. So what we need to find here is area of S2 with respect to area of S1. So let's call it dA2 by dA1. Rate of change of area of A2 with respect to rate of change of area of A1. So this I can write as dA2 by dL2 divided by dA1 by dL2, right? Because remember, there is something called the chain rule, which says to find du by dv. Let us say you're trying to find the derivative of a function u with respect to a function v. You can find the derivative of u with respect to some variable t, provided you divide it by derivative of v with respect to the same variable t, right? And here I'm able to write in respect of with respect to L2 and not L1, because they have given me the value of L2. So I will try to write both A2 and E1 in terms of L2. So let's see how that can be done. A2 is area of the second square. It can be written as L2 square, right? A1 is L1 square, but here L1 is given in terms of L2. That is the second reason I have taken L2 as a variable, right? So L1 can be written as L2 plus L2 cube plus 6, so whole square, right? So now you can find both dA2 by dL2 and dA1 by dL2, and then substitute L2 equals 1. Question 16 again is rather straightforward, because you have a function and it has extreme values at x equals 2 and x equals 1. So let us say this function is f of x. It has extreme values at x equals 2 and x equals 1, which means the derivative at 2 should be 0 and the derivative at 1 should also be 0, right? You have two unknowns and you have two conditions, which means if you write the conditions and solve, you will get the values of m and n, right? So question 16, a very simple concept of differentiation here, that if a function has an extreme value, then the derivative is 0. And yes, the second derivative is non-zero. In fact, to be sure, for extreme value, the sign of the derivative must change, right? In fact, if we're talking about this is a simple problem, so this will be sufficient. But if you go in depth, it is simply not the derivative becoming equal to 0. It is that the sign of the derivative will change from negative to positive or from positive to negative, right? To change from negative to positive, you have to cross 0. Similarly, to change from positive to negative, you have to cross 0. That is why we take derivative as 0 for simple applications, right? So again, question 17, x equals 1 is a critical point of the function. So what is a critical point? A critical point is a point where the function is either the derivative is 0 or not defined. Either the derivative is 0 or it is not defined, right? And here we have an algebraic function multiplied by exponential function, which means the derivative will be defined, right? Because uh, polynomials are differentiable, exponential functions are differentiable, which means the condition we are trying to apply here is the derivative of the function should be 0 at x equals 1. So that means f dash 1 equals 0. If you apply that condition, you will get the value of a, right? And then you can check for local minima, local maxima, right? If you remember conditions for local minima, local maxima, what is the condition for local minima? The derivative must be equal to 0. The second derivative must be greater than 0. And for local maxima, the first derivative must be equal to 0 and the second derivative must be less than 0. So let's move to the next question here. So a function is given, you have to find whether it is continuous and differentiable. So naturally, we will start by checking for continuity here. So one important thing here, you have the modulus function, right? So when you're trying to calculate for x tends to 0 minus, that means when x is slightly less than 0, you take mod x as minus x, and as x tends to 0 plus, mod x should be taken as plus x, right? So keeping this in mind, let us calculate the left and right limits of the function, right? So f of 0 minus will be limit as x tends to 0. So I have x e power minus of 1 by, in place of mod x, I'm writing minus x, right? So this will become 0, right? This limit is 0. And if I try to find f of 0 plus, I have limit x tends to 0, x e power minus of, I have 1 by x plus 1 by x, right? So that's the important thing. In the earlier limit, that the term in the exponent becomes 0. In the right limit, the term in the exponent becomes 2 by x. So this is limit as x tends to 0, x e power minus 2 by x, right? And remember, this is 0 plus if you want to be specific, right? Now, as x tends to 0 plus, we know that 1 by x tends to plus infinity, right? If as x tends to 0 plus, 1 by x tends to plus infinity, which means minus 1 by x tends to minus infinity. So that means e power minus 1 by x will tend to 0. That means this limit is also 0, because x tends to 0, e power minus 2 by x also tends to 0, right? That means the left limit and the right limit are equal, and they're also equal to the value of the function, which means the function is continuous. Now to check for differentiability, you have to calculate the left derivative and the right derivative and check whether the function is differentiable, right? So here, so how do we calculate the left derivative? If you remember, in one of the earlier questions, we had applied we had directly differentiated the function itself. So here, if we take the definition, the left derivative, f dash of 0 minus will be limit as x tends to 0 minus f of x minus f of 0 by x minus 0, right? So here, f of 0 is 0. F of x, you should take after replacing mod x with minus x. Right? So this means limit as x tends to 0 minus f of x can be written as, so I will be taking this definition, right? For 0 minus, I will be taking this as the definition of f of x, which will become x minus 0 by x minus 0. This is 1. So the left limit is, the left derivative of the function is 1. Now, when I'm trying to calculate the right derivative, right? Let us say I want to find f dash of 0 plus. Here, limit x tends to 0 plus. Instead of f of x, I will be taking this function, right? This is the definition of the function when f of x is greater than 0, or as x tends to 0 plus, to be sure. So that is x e power minus 2 by x minus 0 by x minus 0. You can see that the right derivative is 0, right? Because x will get cancelled out. And like we discussed earlier, e power minus 1 by x will tend to 0. So that means the function is continuous, but not differentiable, right? So it is continuous for all x, but not differentiable at x equals 0. Question 19 is something similar, the left-hand derivative. That means you have to find limit x tends to k minus step of x sine pi x. Oh, sorry, the derivative, sorry. So you need to find limit x tends to k minus f of x minus f of k by x minus k, right? So we will be writing limit as x tends to k minus f of x is step of x sine of pi x minus step of k sine of k pi will divide by x minus k. Right? This is the limit that needs to be calculated. Now here, x tends to k minus, which means step of x will be k minus 1, right? Because if x tends to k minus, it means that x lies between k and k minus 1. And if x lies between k and k minus 1, what should be taken as step x? K minus 1. So you will get limit as x tends to k minus 1 sine of pi x. And you will see that this is this is 0. This is 0 because sine of k pi is 0. Sine of any integer multiple of pi is 0. Whole divided by x minus k. Right? Now this is a limit of the form 0 by 0. You can use L'Hopital rule to evaluate it. So you will get limit as x tends to k minus derivative of the numerator is k minus 1 cos pi x times pi and derivative of denominator is 1, right? Now if you apply the limit, you will get k minus 1 pi times cos of k pi. And what is cos of k pi? Cos of any integer multiple of pi can either be plus 1 or minus 1. And that is defined or that is decided by the integer k, right? You can write this as minus 1 power k. For even numbers, for even multiples of pi, you should get plus 1. For odd multiples of pi, you should get minus 1. So we can write that as minus 1 power k, which means the answer is minus 1 power k times k minus 1 times pi, right? So I hope you recall the earlier point when you're using left-hand derivatives or right-hand derivatives. If you don't know whether the function is continuous, it is best to go by the definition. If you know that the function is continuous, then you can differentiate and substitute the value, right? So that was question number 19. Question 20 is again related to the previous one of the previous questions here. Here, y is in terms of t, x is also in terms of t. You want to find dy by dx, which means you find the derivative of y with respect to t and divided by the derivative of x with respect to t, right? So y and x are given. You can find both dy by dt and dx by dt, right? So question 21, a parallelogram is constructed on 3a bar plus b bar and a bar minus 4b bar, where mod a equals 6 and mod b equals 8, and a bar and b bar and a. Okay. Something not clear about this. I think this is a misprint. So that may not be sufficient information to find the question, to find the solution here, right? Because let's look at the rest of the question here, right? Let's try to find the length of the longer diagonals. The first diagonal, let us say, is p bar. The second diagonal is q bar. Then the lengths of the diagonals will be p plus q. Sorry, let us say the first side is p bar, the second side is q bar. Then the diagonals will be p plus q and p minus q. So the lengths of the diagonals will be modulus of p plus q and modulus of p minus q, right? So what is modulus of p plus q? Modulus of p plus q is 4a bar minus 3b bar. Modulus of p minus q is 2a bar minus 2a bar plus 5b bar. Now either of these could be the longer diagonal. And to find the length of the longer diagonal, you need additional information about them, because how do I calculate modulus of 4a bar minus 3b bar? We know that modulus of 4a bar minus 3b bar whole square can be written as 16 mod a square plus 9 mod b square minus 2 times 4a dot 3b. In fact, I'll get 16 mod a square because 4a dot 4a is 16 times a dot a, that is 16 times mod a square. So this is 16 times mod a square plus 9 times mod b square minus 24a dot b, right? Similarly, modulus of 2a plus pi b whole square is 4 times mod a square plus 25 times mod b square plus 20a dot b, right? So in either case, we need information about A dot B. Unless you know the value of A dot B, this question cannot be completed. Okay, so let's leave it at here. If any information that helps us find A dot B is known, then we can find both lengths of both diagonals, and then the answer would be whatever is the longer diagonal, right? So question 21, I think you could have skipped during your exam because it did not have sufficient information. Question 22 is again similar to something we did earlier, right? Foot of the perpendicular. So you have a line passing through alpha comma 7 comma 1. From some point 1 comma 0 comma 3, a perpendicular is dropped. And this point's coordinates are 5 by 3, 7 by 3, 17 by 3, right? So let's call these points A, B, C. So it is clear that the angle at B is 90 degrees, which means the vectors AB bar and BC bar are perpendicular. That means AB bar dot BC bar is 0. So if you apply that condition, you will get the value of alpha. Question 23, normal to the curve at the point 1 comma 6 makes intercepts 1A. Okay, so how do you find normal to a curve at a point, right? So the point is given, you need to find the slope of the normal, right? First, let's find slope of the tangent, right? Slope of the tangent is dy by dx at 1 comma 6. Now, y and x again are given uh, in terms of t, right? So whenever possible, you can write y in terms of x, or you can use the earlier method, right? One way of doing this is writing dy by dx is dy by dt divided by dx by dt. In this case, however, I think you can write t as x plus 1, right? X is t minus 1, so t is x plus 1. That means you'll get y equals 3 times x plus 1 whole square minus 6, right? So that means dy by dx is 6 into x plus 1, right? So that means slope of the tangent is 12, right? When x equals 1, the value of the derivative is 12, right? So that means slope of the tangent is 12, slope of the normal is minus 1 by 12, right? So equation of the normal will be y minus 6 equals minus 1 by 12 times x minus 1. Now from this line equation, you can find both the x and y intercepts. Question 24, number of non-differentiable points of the function. So one important piece of advice here, it is always useful to check at those values, right? Instead of directly going to conclusions, it's always useful to check at values where that expression becomes 0, right? Because if you have some expression inside the modulus function, you have to check wherever that expression is becoming 0. And here in the first part of the function, we have modulus of mod x minus 1, right? Which means we have to first check where mod x minus 1 becomes 0 and also where mod x becomes 0, right? So when is mod x minus 1 equal to 0? This is when x equals 1 or minus 1. When is mod x equal to 0? This is when x equals 0. Right? The second part of the function has cos of pi x, which can either be minus 1 or 0 or plus 1, right? You have cos pi x inside the modulus function. So cos pi x can either be minus 1 or 0 or plus 1. When will cos pi x be minus 1? When x is either minus 1 or plus 1, right? Because for cos theta to be minus 1, theta must be an odd multiple of pi, right? Similarly, for cos theta to be plus 1, theta must be an even multiple of pi. So here that is only possible when x equals 0, right? And similarly, when is cos pi x equals 0? That happens when theta is an odd multiple of pi by 2. So here x can either be minus 3 by 2, minus 1 by 2, 1 by 2, or 3 by 2. Remember, I'm taking values from the interval minus 2 to 2. All these values of x must lie in the interval -2 to 2, and you're checking for cos pi x, right? So based on this, what are all the different points where the definition of the function may change? So there are 7 such points, and sometimes it is useful to check at each and every one of those points, right? So the answer, there are up to 7 points where the function may not be differentiable, but you have to check at the individual points, right? It is possible that at some of these the function is differentiable, right? So question 24, there are 7 values where differentiability must be checked for. Question 25, the minimum value of alpha for which the equation has at least one solution, right? So here, on the left-hand side, you have a function. On the right-hand side, you have a constant alpha, right? So when will f of x equals alpha have a solution? F of x equals alpha has a solution if alpha lies in the range of f of x, right? For example, I do not have solution sin x equals 5. There is no solution for sin x equals 5 because 5 is not in the range of sin x. So here, similarly, if you take f of x as 4 by sin x plus 1 by 1 minus sin x, then alpha should be in the range of this function. So here I have to find out the range of the function f of x in the interval 0 to pi by 2. Right? I have to find the range of the function f of x in the interval 0 to pi by 2. So how can that be done? Right? So here I can say that as x tends to 0, as x tends to 0 plus, rather, as x tends to 0 plus, I can say f of x tends to plus infinity. Because here sin x is in the denominator, right? And it tends to 0 plus as well, right? Similarly, as x tends to pi by 2 minus, I can say f of x tends to plus infinity, right? Because then this term will become 0, but the denominator of the second term will become 0, but it will still be positive, right? So there is no upper limit to the value of the function, right? That means we just have to find the lower limit, that is a minimum value. Now let's see if we can do that using the derivatives, right? So if I take the derivatives, right? So we can do one more thing here. We can substitute sin x as t, right? Let sin x equal t, which means if x lies between 0 to pi by 2, t lies between 0 to 1, and f of x will become 4 by t plus 1 by 1 minus t, which can be taken as another function g of t. Right? So now you have to find the value of the function, the minimum value of this function. So for that, you can use the derivatives. G dash of t is minus 4 by t square plus minus 1 by 1 minus t whole square times minus 1. Right? So that means 4 by t square equals 1 by 1 minus t whole square. So this I have to solve. So 4 times 1 minus t whole square equals t square, which means 3t square minus 8t plus 4 equals 0. Is that it? 4 minus t. Yes. So if I solve this, I will get t equals 8 plus or minus root over 64 minus, I'm not sure if quadratic formula is necessary here, but we are still doing it. It won't be needed here. So I'll get 8 plus or minus 4 by 6. That means either 2 by 3 or 2. Right? So t can be either 2 by 3 or 2. But remember, t should lie in the interval 0 to 1. That is because t is sin x and x lies between 0 to pi by 2. So that means the minimum value you will get at 2 by 3, right? So g of 2 by 3 is 4 by 2 by 3 plus 1 by 1 by 3, right? So this will be 6 plus 3, 9, right? So the minimum value of the function is 9, right? So what is the minimum value of alpha? That should also be 9, right? So that concludes the discussion on the part test. Thank you very much.